Pneumatic shock and turbulence energy generator. This is a concept introduction and working principles video. The purpose of this video is to present a new concept that restores energy from ground vehicle shock and air vessel turbulence. Pistons can be mounted in addition to a ground vehicle shock absorber to displace and compress air or hydraulic fluid to restore energy back into the system, in addition to dampening the effects of uneven terrain. As a ground vehicle drives over terrain, the shock absorber is constantly working, dissipating shock. The vehicle is constantly translating up and down with respect to the wheel of the vehicle. If a piston is placed between the shock absorber, the piston can be compressed during this up and down motion of the body of the vehicle. When the piston compresses, the ground reaction force will be amplified at the larger piston rod. The larger piston rod can collide with the alternator shaft and make the alternator shaft free spin, resulting in battery charging. We can restore a massive amount of energy back into the battery. The fuselage of an air vessel can be broken down into two sections, the frame and the compartment. Pistons can be mounted between the frame and the compartment to displace and compress air or hydraulic fluid to restore energy back into the system, in addition to dampening the effects of turbulence. If turbulence pushes the compartment upwards with respect to the frame of the fuselage, pistons can be compressed. Vice versa, pistons can be compressed to capture fuselage reaction force at other directions during turbulence with strategic placement of pistons. When the piston compresses, the fuselage reaction force will be amplified at the larger piston rod. The larger piston rod can collide with the alternator shaft and make the alternator shaft free spin, resulting in battery charging. We have just restored a massive amount of energy back into the battery. So how does it all work? Let's explore the physics behind the concepts. Pascal's principle is important to understand the concept. Pressure within an enclosed body of incompressible fluid remains constant. If a force is applied to push a small piston, the reaction force applied at the larger piston amplifies with respect to the cross-sectional area of the piston. This is why we're able to lift a heavy vehicle by applying a small force. The equations show a relationship between the force and cross-sectional area. It is also important to understand the conservation of momentum. This image shows elastic collision. The bodies separate following collision. Energy is transferred from one body to the other upon collision. If initial conditions are known, velocities of the two bodies can be computed. Using Pascal's principle, pistons can be sized to amplify the force applied at the smaller piston, to spin an alternator shaft upon impact with the larger piston rod. Archimedes' principle is another important principle to understand. An object placed on a body of water is subject to buoyancy force that keeps the object afloat. A floating object does not induce a reaction force on the bottom platform. Upon combination of Pascal's law, conservation of momentum, and Archimedes' principle, the reaction force as a result of impact with the alternator will not induce much of a resistance from the perspective of the smaller piston. The reaction force will dissipate into the fluid and the body of the two vehicles, where the larger piston is mounted. There is a loss, however. For incompressible fluid, the volume of fluid displaced on both sides must be equal. This implies that the piston on the larger side will rise by a smaller height compared to the smaller piston. This means that we have smaller piston movement on the output side. The winds outrun the losses. For incompressible fluid, the initial and final velocities of the pistons are conserved. This means that if the final velocity of the smaller piston is x, the velocity of the output piston rod will also be x during impact. We have lost piston height, but it's a fair trade. The idea is to let the output shaft with amplified force collide with the alternator shaft. Let the alternator free spin without restricting the movement to the output shaft displacement. And repeat at every iteration with respect to the smaller piston position. For the first iteration, assuming that the mass of the output piston rod and the mass of the alternator shaft is equal, the alternator shaft can be spun with the same velocity of the input piston upon impact. Connecting the alternator to the battery will result in battery charging. The only resistive force that the power supply will witness is the weight of the additional components. The resistive force is much smaller compared to the impact force. The power required to compress the piston is much smaller compared to the power produced by the alternator. More power means more energy. We have recovered a massive amount of energy back into the battery using the hydropneumatic shock and turbulence energy generator. Do you believe that upon combination of the hydropneumatic energy wheel and the hydropneumatic shock energy generator, electric cars can run without needing to plugging into an external power source after an initial full charge? Here's a link to the previously introduced concept, the hydropneumatic energy wheel. Please comment below. Also, do you believe that airplanes can efficiently adapt to a hybrid system using this new concept? Please comment below. Thank you for watching. Please like and subscribe. Stay tuned for future videos.